So in today's lecture, we will be discussing assembler directives. So let us first understand the whole process of how assembly language program is converted to an executable file which runs on your machine. We firstly write a program in our editor which gives an assembly language file with an extension .asm. This is basically our source file. And this file consists of all our mnemonics, for example move bl, al or add bl, al. All such mnemonics are present in this assembly language file. Now this language source file is now passed on to the assembler. Assembler will generate an .obj file, which is nothing but a binary file or an object file which will convert these mnemonics into equivalent binary codes, because your machine understands only binary language, so this assembler will convert your mnemonics into machine understandable codes. Up till now we don't have any information about at what particular location in memory this code will be stored, where data, variable or constants used in program will be stored. Since we are dealing with low-level languages, such things need to be directed by the programmer, unlike high-level languages. So here what assembler has done, it has just converted this into an equivalent binary code, but has not specified at what particular location this codes will be stored. So we move on to next block, which is linker/locator. What a linker does is, if you have more than one object files in a project, this software will merge them into one or link them into one. And what a locator does is, locator will assign memory locations to your program or code where exactly these programs will be stored, and finally this .exe or executable file is generated which runs your program. So moving on. An assembler is a program used to convert an assembly language program into the equivalent machine code modules, which may further be converted to executable codes. This we have seen in our previous slide also. So the assembler decides the address of each label and substitutes the values for each of the constants and variables. It then forms the machine code for the mnemonics and data in the assembly language program. To understand these two statements, let us come to this instruction example. Start move ax, bx, copy bx into ax. So this copy bx into ax is your comment, which is just to increase the understandability of the program. So this need not be converted into machine code. This move ax, bx is your assembly language instruction, which will be converted by the assembler into corresponding binary or machine code. This start is your label. This signifies the memory location at which this instruction move ax, bx is stored. So while converting this move ax, bx into binary or machine code, assembler will also replace this label with the binary location where this instruction is stored. So for completing all such tasks, an assembler needs some hints from the programmer. For example, the required storage for a particular constant or a variable, logical names of the segments, types of different routines and modules. Routines and modules are nothing but it may be your short programs or function programs, etc. So such type of hints are given to the assembler using predefined alphabetical strings called assembler directives. So let us move to our first directive, which is db, define byte. The db directive is used to reserve byte or bytes of memory locations in the available memory. While preparing the exe file, this directive directs the assembler to allocate the specified number of memory bytes to the set data type, that may be a constant, variable, string, etc. So you might want to use a variable in your program, and to use that variable you have to first get it stored in memory. This is what this directive helps in. Suppose you want to use variable name nut whose value is 01h in your program. So DB will reserve 1 byte memory location in your program and initialize it with 01H. And this allocation of location is assembler dependent. And to keep track of this location or to save this location or to avail this location for future use, assembler will assign this offset address of the reserved byte to none. Let us move to the next example. We can also define an array using this directive. For example, this list db 3ah 49h 34h. This instruction will direct the assembler to store 3 consecutive memory locations of size 1 byte each. This will also be assigned automatically by the assembler. Here we can see starting from 3ah, the next is 49h and the next one is 34h. And similarly, the offset address of the starting byte of the array will be stored in the variable list. Now moving on to next example, we can also reserve a byte location without initializing it with any value. For example, num db. Here we have not defined any value for this variable num. So what will happen here? A byte location will be reserved here without value initialization. We can use this variable later. For example, if we want to calculate sum of two numbers or product of two numbers, so output will be defined later. Output result will come later, so that will be stored here. We can also use this directive to store character strings in memory. To store character strings, assembler will use corresponding ASCII codes of those characters. For example, we can see here there is a character string name message whose contains R hello. So this DB directive will first check the length of the string. As we can see here, the length of the string is 5. So since 5 characters are there, so 5 bytes will be required to store the string. So say to store H, its ASCII code 72 will be stored. To store E, its ASCII code 69 will be used, and so on. Now there is another directive DW, which is defined word. This directive serves the same purposes as the DB directive, but it now makes the assembler reserve the number of memory words instead of bytes. So this directive will be reserving 2 bytes instead of 1 byte at a time, as was the case of DB directive. So if we say this example, we see there is an array named words which is having 3 words to store. So to store these words, we will be needing 6 bytes memory location. So firstly, this 16-bit word will be divided into lower byte and higher byte. This lower byte will go into the lower order address and this higher byte will go into the higher order address. Say for example, this 1234H. Here 34 is the lower byte and 12 is the higher byte. So 34 will move into the lower order address and 12 will move into the higher order address. And the same will follow for other bytes as well. Now there is another usage of DW directive. Suppose we want to duplicate values in an array, so we may use it like this: W data DW3 DUP 6666H. So this statement will reserve 6 bytes of memory locations for a word labeled W data, and this DUP will duplicate this value given in statement in all reserved memory locations, as you can see here. On the similar lines, we have 2 more directives: DQ define quad word and DT define 10 bytes. This DQ directive is used to direct the assembler to reserve 4 words. 4 words imply 8 bytes of memory for the specified variable and initialize it with the specified values. The DT directive directs the assembler to reserve 10 bytes of memory for its storage and initialize the 10 bytes with the specified values.